So last summer we had a huge forest-wide effort to survey most major water bodies for Elodea. So we hit the Kenai Peninsula area of the Chugach, western Pennsylvania Sound, and some spots in the Copper River. And we surveyed 12 lakes on the Kenai Peninsula. These lakes on the western Pennsylvania Sound, we prioritized these based on if they were near cabins or canneries, etc. And then on the East Delta, we knew from fisheries surveys that it was there in 2012 in Martin. And so we surveyed some other lakes out there to see where it was at. And this is what it looked like, how we surveyed. It was blacks really, we were in little pack rafts with rakes on ropes. And for the most part, we could just visually look in the lake and see with polarized glasses. But every now and then we'd do some random rake throws and pull up the vegetation to make sure we were staying. And so here's what we found on the East Copper River. Martin Lake, which we knew was infested, we took an airboat and checked out the majority of the lake and found it growing thickly throughout. It was not upstream in Pothole Lake or in the little stream connecting the two. It's all over Barron, but not in Little Martin, which is encouraging, or Token, or Kishtikau, which isn't surprising because it's a really pretty turbid lake. And this is what it looks like in front of the Martin. And Martin was probably the most alarming infestation that we saw. This is Sean Mead, the poster boy of Elodea surveys here, with a rake full right in front of the cabin. And as you can see, it just grows in these dense, thick mats, and it's like this throughout the lake, but especially prevalent in front of the cabin. And I had a chance for some opportunistic surveys out on the Delta with the wildlife crew doing Nest Island monitoring. And we got out and did this unit 20 off of Eyak River there. The reason why we selected that unit is because it's known to flood periodically in heavy rains. And we know Eyak Lake has Elodea in it. And sure enough, the red, of course, indicates an Elodea infestation. Green indicates where we surveyed and didn't find it. So not surprisingly, we found it in the ponds just adjacent to where it would have flooded from the river. But interestingly enough, we found this, slough running through all of these ponds. It was absolutely choked with it. But not a stone throw away in ponds nearby, there wasn't any. And then this is some side sloughs with the wildlife crew found some additional floating fragments and parasites off of Elodea. Elodea flows from McKinley, which we knew from surveys in 2012 had Elodea. So overall, across the forest, we did not find Elodea on the Kenai side. We did not find it in western Pennsylvania Sound. We just found it outside of Carolina, Copper River Delta. We didn't find it in Texas. So these blue dots, here's what we have planned for next summer. These blue dots are where there's artificial dusky nest islands across the delta. And next summer when we go out with the wildlife crew to do monitoring, we're going to survey all of these ponds for Elodea so that we can have a better idea of where it is across the delta. And here's an up-close look at what those ponds and nest islands look like. That's it. Any questions? Yes.
What depths does it grow? 1 feet, 2 feet, or 10 feet deep?
It's more like 4 to 8 feet, and there's people in the room that have a better number than that.
It could grow down to 10 or 15 feet.
Okay. It seemed like we saw it in Martin at a very distinct band, and I'm not exactly sure what that was, but
Yeah, it kind of starts at 3 or 4 and then eventually starts.
yeah, the shallower areas there was a lot of other vegetation, but not Elodea, and then there's certainly deeper areas.
I'm curious, when you sampled Cogtail Lake, where did you sample? I know there's a cabin on the outlet side, there's kind of a little bay, and then before it opens up into the big lake.
Well, we sampled where the cabin is, and that turned out to be probably the most suitable habitat. And we also got into the big, because it's a huge lake. We surveyed about a quarter of the big lake, but it was really deep, and it was probably pretty unlikely. But I think that Cogtail should get on our monitoring list at least every 3 or 4 years.
I know there's a lot of floatplane
because
traffic.
it gets a lot of floatplane travel, and it's a really pretty shallow high probability water body.
I know that we had kind of thought that possibly in some areas that Elodea might be getting pushed back up some of the sloughs with the coming tide. With
Right.
some tide channels and such. Do you think that is in fact happening?
It sure looks that way from that. I mean, you can't hardly see, but there's this, we found it in this really, it seemed like pretty random spot. There's a little red dot there. And that, in this, I kind of wonder about that too.
Yeah,
But
so-
we need to, we need more surveys to kind of fill in that area to get a better distribution.
Anything in estuary influence at all?
It appears to be salt intolerant, so we didn't find much, no. But again, we have a lot to survey out there. Yeah.
Thanks, Steve. Next up, we have Dr. Lars Anderson, who is retired from USDA and now does some consulting work with Water Weed Solutions, and he also started with UC Davis.
Thanks, I'm going to keep this really informal, so if you have questions in the middle of my talk, just interrupt me. I think I have a couple of objectives. One is to make you feel really good because you're not alone in this problem. The lower 48 has been dealing with invasive aquatic plants for the last 60 or 70 years. And this is not the worst one. It's one of the bad ones. I'm going to show you some examples of some that are even harder to get rid of, and we've managed to do that, just to give you some encouragement that you can actually eradicate these problems if you catch them in time. Just by the way, there we go. That's actually a small pond have you been to Point Reyes before in California? Well, this is the sad story of the cat from South America. This is actually a pond covered with parrot feather, which is on your list too, I think, up here to look for. And that's a big Cestero out of your beautiful area. But you're not alone. We've got these invasive plants all over the U.S., all over the world, actually. So there are ways to deal with it, and so you're not reinventing the wheel. I think that's part. So I'm going to talk about how we all believe we understand water and how important it is to us, how you define problems. Actually, you've got a good definition of the problem already, and you're already on track to eradicate it. I want to convince you that that's the right thing to do. So there's some examples of hydrilla, actually marine algae that we eradicated in California. Another water weed, a couple of them, your rainwater milfoil, you've heard about that all over the U.S. And some new technologies, which I may have time to get into. At some point, I'm going to invite Andrew to come up from CPRO to talk to you about some particular herbicides that are suggested to be used, have been used. Water is really personal, and you know, it's one thing to go out into a cornfield that you're growing corn for, you're going to produce it, you're going to do fertilizer, you're going to harvest it. It's another thing to talk about what you're going to do in a lake that you swim in, fish in, or do other kinds of recreation in, or where you have fisheries habitat. So it's really important, it's personal to us all, rather important. This is the Sacramento Delta. That is another plant in the upper left in the same family as Elodea, Gary Densa. That's what it used to look like. It's been under control now for the last 8 years in the Delta, using a variety of methods, but primarily aquatic herbicide. That's what it used to look like in one of the housing areas down there. Solid plant across there. You can imagine what it's like for a fisheries habitat below that. Dissolved oxygen is very low, and there's no access for waterfowl and so on. The good thing is that through both federal and state agencies, there's a lot of concern about water quality in this country. And we don't think about this all the time, but all these agencies are involved with one way or another protecting our water quality and our water resources. And part of that is including invasive plants and animals that get into those areas. So you probably, in the audience today, you fit into one of these categories, I'm sure, whether you're an agency person or a public is concerned about what's happening. And just to give you some idea of what these plants will look like, this is kind of a regional view of these plants. Hydrilla all over the place. to do with Elodea coming in. But we've actually got plants that haven't come here yet that easily can make it. These are cold water species that are actually being moved around by inadvertent purposes, or sometimes they're purposely moved around because we don't know what they do. But the point I want to make is Elodea is not the end of it. You're going to have to be very vigilant about keeping other species out of Alaska. It's going to be a constant job to do that. This is one of them called Trapper. It's all over the northeastern U.S. That fruit is about the size of a nickel. It's got spines on it. And it would love to be in Alaska, I'm sure. It would do really well here. This is one we don't have yet. It's actually called oxygen weed. It's in New Zealand and some areas in Australia. And it behaves very much like Elodea, hydrilla. They're all in the same family. Those are. Trapper's not the same family, but those are. So, here's all the impacts we're concerned about, and we've sort of covered some of those. Basically, these plants, when they get and grow where you don't want them to grow, or they grow in too much abundance, have some impact on either how we use the system or how the water quality is maintained, affect sediment loading. And they, as long as they're still there, they are sources for further spread. And I think that's the critical reason that you eradicate rather than just try to manage at some level. So here's some examples of the cost of these. In Florida, we're spending about $50 million a year just to manage, I don't mean eradicate, manage hydrilla. In California, we're spending about $3 million a year. We've been eradicating since 1976. So the difference in cost is how we're approaching it there. Here's the Elodea. We're managing it for about $5 million a year in the Delta. Here's the original milk well. This is water hyacinth. You all probably heard about that. U.S. management costs. Point is, these are expensive plants to control once they get established. Here's that marine organism I'm telling you about here. We spent $7 million to get rid of that at 2 sites in California. It's gone now. And here's some others. So maybe about $300 million per year or so in the U.S. just for the cost of control. That's not the cost of the impacts of those plants, that's just trying to control them. And so here's some of the losses that can be created by these plants when they grow out there: jobs, property values, all these things. So if you let something like Elodea continue to spread in Alaska, those kinds of things, you'll be beginning to see those kinds of impacts if you go back quickly. So this is the estimated, there's a huge estimate here, $1 to $2 billion a year for these costs. And it's really that huge number of range because nobody really knows for sure what those costs are. They're high. So what you're trying to do is balance this ecosystem that's out here. On the left-hand side, you've got nuisance species coming in. You're trying to do some action over here to protect what that ecosystem is supposed to be doing. It's either doing something for itself, for the fish, for example, or something that we want, which we call ecosystem services. That's water, recreation, potable water to drink. So what we do there makes a huge difference. Because everything we do in those systems affects the fish, the invertebrates, the plants, and they have all, we're concerned about all these things. You've already heard about the pathways and vectors, the flow planes that can move these plants around. The most important thing you can do as part of an eradication project is to stop the movement, contain it where it is. So you have to put some big effort into this whole issue of pathways and vectors as well. So I talked about earlier, mentioned the behavior we have about water. We're really personally involved with it. It changes how we look about what the risk is from these plants or any pest that we're dealing with. But it also has an effect on our perception of the risks of what we do to manage that. Okay. Hopefully, at some point, this gets filtered to a science-based approach that comes out with a consensus for action. And for all the successful eradication projects and management projects in the lower 48, this pretty much has been the process. It doesn't always go a straight line, but that's pretty much been the process. And if you don't do this, here's what can happen. This is a process of invasion. So the earliest record was 1982 for Elodea. That means it was probably there before that, maybe 5 or 10 years, who knows. We've had species that have been around for 5 or 10 years and then have done nothing until the 15th year out or the 20th year out because something changed, either genetically or the conditions. If you let it get established, you have to contain it and eradicate it. If you don't, you wind up spending a lot of money just to manage it to some acceptable level. Yeah. That costs a lot of money. So it's all about time. So here we are, we're somewhere in here someplace. If you wait too long, what happens is your choices get fewer and fewer, and the concerns you have is that what you do if you wait too long is you have more risk to non-target species, fish, other plants. Your options are limited. So you're kind of right in this place here. You've got to start doing something pretty quick to do this pretty early at this point. Okay, so it's a little complicated. I want to point out that we've got 3 kinds of aquatic plants. We've got floating, emergent, and submerged plants. This is Elodea, fits right in this group here. Sometimes you can change the ability for a plant to grow by just changing the resources it has, light, nutrients, maybe its temperature. In most cases, when the natural system, you really can't do that. So we're kind of out of luck at this point. Can't really change those conditions very much. So, the concern we have with these plants once they establish is this movement for transport. Here's what you have to get those fragments. You can look in the tank back here. They only have to be about 1 inch or 2 long to start a new plant. It's so effective. You've got to produce these viable propagules or fragments up here in the left-hand circle. You've got to move them, which is the float planes, boats, waterfowl, upflow of a river. I'll show you a picture of that in a minute. You know what happens upstream goes to downstream, and that's how they move. But you also have to have a suitable habitat, which is the bottom. So the other question is, if you have 100 lakes out there, are there 100 suitable habitats for this? Maybe and maybe not. But that's something you have to figure out as well. But once you have something started, you don't want to take the risk that you've got another 50 suitable habitat lakes out there. So, this was taken this afternoon at the weir, and that's all really across the dam. Fortunately, it's going to go downstream to the ocean at some point, but what that means is this whole lake, as you've already heard, is a huge source for further transport of Elodea. So I don't want to be alarmist, but I really do, because you need to act. So if you look at the zones, I just put a little red box here where the zones are. You've already seen the detailed locations, just as a zone. And imagine if you don't do anything in the next 5 to 10 years, maybe 25 years, what can happen? So we don't want that to happen. And that is the reason you have to eradicate rather than just manage. This probably summarizes the best approach that we've found, at least in the lower 48 and in other countries, for dealing with these kinds of pests. So, top, you have to understand enough about the biology of the plant and its phenology, how it grows, where it grows, and how it reproduces. You have to have enough knowledge about these sites to know what the pathways are for movement and transport and vectors. You need to know what the laws are, the regulations that allow you to do something in that site. And that's a really important issue for Alaska and for California. Both of these states have multiple owners of these waterways and water systems. So you have to get them together, coordinate what they do. Otherwise, you'll never, someone mentioned it earlier, you treat one like you've got to treat them all. So you have to look at it at the statewide level. You really do. Then you have to have the capacity to act. That comes from the knowledge on the field of how to implement a program, and resources and funds to do this. If you don't have these components together, you can get something started, but you're not going to be successful at eradicating that particular pest. This is the lesson that we've learned from successful programs and those that have not worked very well. We need these components there. And another example where we know that something Elodea started and didn't get control is this funny back up here in a minute. So this is lots done. That little circle shows an area that had started out with a small infestation of Elodea. And this is the time frame, prior to 1900, the 50s, and then 2008. And that's the spread of it, when they did nothing. And that's not, that latitude is not that much lower than where you've got it now in the southern parts of Alaska. So that's kind of a lesson to look at. You don't want to follow that. We have been successful. These are just lists of successful eradication and management programs for similar aquatic species. So what I'm trying to say is that you can do this. It's not easy, and it takes multiple years to do it. And here's the difference between three options you may have. One is to do nothing. I think you probably may be convinced that you don't want to do that. You can manage to some threshold that you may be satisfied with for a particular lake, but remember that lake will continue to be a source for further spread. The trouble is, this is a long-term use of whatever management, whether it's mechanical or herbicides or anything, it doesn't stop because you've got to keep treating it to keep it that level that supposedly is acceptable. On the other hand, with the option to eradicate, eventually your readiness for the next invasion is heightened. Your costs are lower over the long run because eventually all you're doing is monitoring periodically to make sure you've got rid of it. You're not continuing to treat. And so these are the methods that have been used across the person who surveys all the time. You have to do that. Physical barriers, dredging, all these kinds of things, vectors, herbicides. It's a process, and you use all the tools you've got in the bag because if you don't, you might miss something. And that's the other important thing. When you sit around the table, these groups get together. We typically form teams to do this. Every method is on the table to start with, and you start taking them off the table as they don't fit. Look at everything. That's the process. And then you go back again and keep doing it until you've got the job done, which may take 3 years, it may take 10 years. But you can do it. So here's some hydrilla history. This is hydrilla. It's the same family as Elodea, that it forms these tubers that last 7 to 10 years in the sediment. And when the turion will break off the plant and drift around, so that's another pathway to survive. Plus, all these fragments, the same as Elodea, all it takes is 2 or 3 inches of that to start a new plant. That's pretty serious. California first founded in 1976, started an eradication program because of the threats that were there. Both of the areas that have been eradicated in California, and that's already about 2 years old, so there's another 3 or 4 that have been. And here's the kinds of systems that just in 76 we founded. The whole process of getting rated as A-rated pest, and almost all the sites have now been eradicated. We have 3 or 4 active sites we're working on. And here's the diversity of sites: 10-acre ponds, 500 miles of canals, flowing systems. You can do this. It can be done. So just to give you an example of the difference between eradication and management, here's the southeastern states of hydrilla. Here's the western states. And it's not because we don't have so many rivers out there, because here's the river system. Here's the western states, here's the northeastern states. The difference is that California took the eradication mode in 1976. Florida, when it first got hydrilla in the late 50s and 60s, and all the way up until the 1990s, took the management mode. And that's the big difference. These are plants in the Delta of Sacramento. Has anyone been to the Delta in California before? Major drinking water for 25 million Southern Californians. We've got our own problems out there. We've got water hyacinth out there. We've got Elodea, and so on. We have a new plant called sponge plant, which is from South America. We have a lot of South American and European plants that are not native. And you can use some of these physical methods for some of the floating systems. These are floating plants. So the canal was completely cleaned out by doing this. They didn't have to use herbicide because the plants were floating. They could just take them right out. You can't do that very well at all with these rooted plants like Elodea. A sad story. Who's been to Tahoe before? Okay. This is a lesson on why not to wait, why you don't want to wait. That's the Tahoe Keys Arena. It's 1,500 homes and 170 acres of water, and loads of Eurasian water milfoil, Pintail and curly pond. These 2 are invasive, non-native plants. This is a native, but it's growing in a nuisance proportion in that system. And you can't use herbicides at this point, although it's on track for the next few years. So all I've been doing is running a harvester. Right back at that. That's what they're doing. And you can see when you run a harvester, you get fragments off the thing like this. They haul it away. They spend $400,000 a year on 150 acres every year. The 4 harvesters. For the first time, we started looking at the fragments produced by this last summer. That's this summer of 2014. So I put a study together and looked at these 4 sites. We ran nets back and forth after the harvesters had gone through there. We wanted to know, do the harvesters create more fragments, or is it just our imagination they do it? Okay. Back up. Too fast. So those are the sites. So after we did our tracks, we calculated the fragments per acre And all the right-hand side bars are after the harvester had gone through. The blue bars are. And there's a reason that there's fragments before, because you've got plants growing, you've got boating activity going on, producing these fragments all the time out there. So imagine your lake's out here with Elodea, halfway up or to the top, boats going back and forth, float planes going back and forth. You're creating this huge tropical pool out there that can move around. And then if you look at the total number of fragments per acre, 3,500 to 4,000 fragments per acre in one harvest operation. And all of these are viable. And some of these are like an inch long, and some of them are 2 or 3 feet long. Here's the total fragment length, you add it all up, everybody look at it. No matter how you look at it, the harvesting operation is creating huge numbers of viable fragments out there. So that brings up the question of how do you use and can you use herbicides? So I just used this little diagram to show you that there's ways of getting herbicides into aquatic plants. We're concerned about submerged plants with Elodea. You can put the herbicide in the water, you can put it along the soil with pellets. You can drain the water, you can actually apply it to a drain, dry but wet surface of that lake or shoreline and be effective that way. The thing you have to be worried about is what happens to that herbicide when it gets in the water. All the things that can happen. The breakdown, which they do, get taken up by the target plant, the non-target plant. So all these things have to do with what happens after you put that herbicide in the water, and over time it's going to dissipate and break down. Get transported as well. Each herbicide has an active ingredient that has a certain amount of time and has to be in contact with the plant to work. And I just showed this on a graph here. From very fast-acting herbicides to ones that take longer. But the interesting thing about these, such as fluoridone, which has been used in quinine, is that it takes longer, but you use very, very little of it. We're talking parts per billion over a several-week period. So you're using very little of that. But it has to be in contact for a long time. I'm not going to get into these are the active ingredients. I'm not going to get into those too well. But something else to remember from this discussion is this is the component of a successful aquatic herbicide program. It has to be in the right place. It has to be the right concentration and contact time in the right herbicide. And the right mode of action. Mode of action is how does it work? What's the active ingredient? And the reason I'm mentioning this is that you should be aware of this is simply because there are different modes of actions for different herbicides. And that's what makes some of these selective and some of them not so selective. And actually, a good time, you want to talk about selectivity and fluoridone? Sure. So Andrew's with CPRO. He's going to spend a couple of minutes talking about selectivity and how fluoridone works. I think that'd be great. Is that okay?
Great, thanks, Lars. Just for something, anyone I've talked long enough? Everybody still awake in here? Yeah. I'm Andrew Skibo. I'm the R&D lead for CPRO Corporation West. I'm out of Fort Collins, Colorado, but I've been involved with the folks on the Kenai for 3 years running now. I was on site for the treatments last year, and we'll present, I think, some of the data when John gets up to speak today. So I represent the company that produces sonar. The active ingredient in all sonar formulations is fluoridone. We talked about some toxicity, but I think immediately to address a question that had been asked earlier is, well, how do we put this product in, or how do we put this active ingredient in and only attack that species? So first, let's talk about the mode of action. How does this herbicide work? When it's taken up by a plant, this has to be a photosynthetic organism. When it's taken up by a plant, ultimately it inhibits the formation of carotenoids. What carotenoids? It's 7 o'clock at night. We see trees in the fall, right? And they change colors. Well, why do trees change colors? I don't have any prizes to give out. Does anybody want to answer that question? Nobody? Come on, this is awesome. Trees change colors. They don't really change. It's that the chlorophylls have died off in the tree. As the tree goes dormant for the winter, as the leaves prepare to senesce or fall, the chlorophyll dies off. And what you're actually seeing are the carotenoids, the secondary pigments. They're present all year round. It's just we don't see them because the green covers them up. Well, secondary pigments are really important to plants. It's basically when they intercept sunlight, they have to step that in.